So good morning, students. So in the last lecture, we see the different types of steel properties, mechanical properties, right? So I will show you them first. Uh, we discuss about what are the chapters included in this subject. What are the meaning of steel structures? What are the sections, common section? What are the basically steel buildings, steel structures available in which form, which is the bridge building, industrial building, truss bridge, suspension bridge, cable straight bridge, right? And what are this little bit advantage and disadvantage of the steel structure compared to mostly comparative to concrete structures. And then going forward, properties of the steel, which is the physical properties and mechanical properties, in which we identify the grade. How do we identify this is the term of the steel grade given in this different types of catalog available for the company, right? So there are different types of steel, and their properties are different, their ultimate tensile strengths are different, yield stress is basically depends on this thickness, right? So its modulus of elasticity, Poisson's ratio, and its density we learn, right? Then going forward to the different properties, which is the ductility, toughness and brittle, fracture, temperature, corrosion, hardness, fatigue, etc., etc. And we learn about the steel sections. What are the steel sections used in the steel structures, right? So which is I section, T section, channel sections, angle sections, steel bar, tubes, plates, sheets, strips, etc., etc., right? But one thing note here that uh, for the construction or for the design of the building, we definitely refer the structural engineering handbook or the steel table for the sectional detail, right? So basically steel table given you the idea about what type of section you choose, what type of grade you are using, and depends on that it's provided different properties for the different types of properties are given in this steel table, right? Which is elastic modulus or different types of width, depth, its thickness, right? Which depends on mainly what are the steel section you choose. These are this sections which are actually looks like, right? First one is a T bar, then angle section, wide flange, I beam, and channel section. Now we starting with our lecture is rolled steel eye sections, right? So there are basically there are five types of eye sections provided in our steel table, or like, so ISJB, whenever mention this name, ISJB means Indian Standard Junior Beam, right? Then going forward, ISLB means Indian Standard Light Beam, ISMB means Indian Standard Medium Beam, ISWB means Indian Standard Wide Flange Beam, and the last one is the ISHB, which is Indian Standard Heavy Beam. So this basically I section depends on the beam, right? Which is junior, light beam, medium beam, wide flange beam, heavy beam, right? For example, if in example given that ISMB 500 and 0.852 kilonewton per meter, here uh, this 500 ISMB 500 defines depth, mostly 500 defines its depth, and 0.852 kilonewton per meter is basically weight per unit length, right? So you identify this type of ISMB, what is its depth, what is weight per unit length, right? So here the figure is, here this top and bottom portion is known as a flange, and the central vertical portion is known about the weight, right? So this TF is the thickness of flange, and the last one is a TW is the thickness of well. This total, the starting from the top portion to bottom portion, is the depth, which is considered as a small d, right? And this width of this flange is known as a BF, right? So actually, I section is looks like this, right? As you shown in this figure, this I section is which is provided here, right? So in beam column construction, there are also different types of floor girders, floor beam, uh, exterior column, floor slab, interior column. So this I section, you see that this I sections provided in the floor slab, right? This I section, I section, I sections, right? So basically, this type of I section used mostly in the steel structures. Now, a roll steel channel section. uh, I will tell you about the channel section. Channel sections means the section in a C shape, C later shape, right? So there are ISLC, ISMC, ISLC, ISSC, right? So which is Indian standard special sections, right? So basically, if the example in the example, the given data is ISMC 300 and 0.351 kilometer per meter, hence 300 means it's a depth. So we know that the depth is starting from the top portion to the bottom portion, right? So its depth is 300 mm, right? And other properties like its weight, its thickness, which all are provided in your steel table. You can easily see that. And here 0.351 is weight, right? So okay, so say this one is a flange, top and bottom portion is a flange, right? And this central portion, vertical portion is known as a web. So here these are provided as a C section, right? So C sections as provided in this structure, as you can see that. Next is a roll steel angle section. Angle section is identified as L shape, L, right? So ISA equal angle is, what is the meaning of ISA equal angles and ISA unequal angles? Equal angle means its width and depth both are the same, so it's known as equal angle. If the B cross D is different, then it's known as an unequal angle, right? And at the end of this section, 12 is considered as a thickness, right? So here B cross D cross T, right? So if B cross D, B and D width and depth are same, then it's known as equal angle. And if the width and depth are not same, then it's known as an unequal angle, right? So here different types of angles provided. First one is equal angle, second one is unequal angle sections, and the third one is a bulb angle, right? So in this first equal angle, L, its width and its depth both are same, then it is identified as L, only L, because both are the same. And the second one is L1, provided as L1, and second one is L2. So because of that, L1 is considered as a different length and L2 as a different length. Both, for in first example, L we both consider width and depth as a L, right? It means both are the same. And in the second one, unequal angle, it is identified as a L1 and L2, right? And in the third one is a bulb angle, right? It's obviously width B and depth provided. We don't know if the width and depth are same or not, but here the bulb, here in the top portion, the bulb size, some portions given in the top, right? So because of that, it's known as a bulb angle. So here channel sections mostly used in this transmission towers or television towers, or what other types of tower you can see around your area, right? So mostly in the steel structure, mostly in the transmission towers, L shape means angle sections are generally used. Next is a roll T section. The first one is ISNT, which is Indian Standard Normal Beam. Second one is ISHT, which means Indian Standard Heavy Beam. Next is ISLT, which is a special legged beam, and ISLT is light beam. Right. So T section is identified as a shape of a T letter. Right. So here you can see easily that the T shaped T sections provided. Right. So here in this step, the distance between top and bottom portion is known as depth, right? The central vertical portion is a web. The upper portion, which is known as a flange, right? Here, different types of different types of wheels are provided. Here, fillet wheel is provided, right? So these are the T sections, right? So what are the other sections? So in the steel bar, ISRO means Indian Standard Round Bars, and ISSQ means Indian Standard Square Bars are provided, right? Next one is a steel tube, and then the steel plates, right? So this all are provided, this all types of sections using in what type of structures. So first one is a braced frame, right? Here bracings are provided, L type, K type, right? So this all are used as a steel section in steel structures. Second is moment resisting frame, and the last one is a core and suspended floors, right? So for this core and suspended floor, steel tubes are used at the central portion of the structure, as you can see that, right? Next structure is a tapered portal. Next is a lattice girder. Next is pylon, knee brace, cable stray building bridge, sorry, cable stray bridge, and the last one is a suspension bridge, right? So this all type of structure, this different types of channel sections, I sections, C sections, angle sections, this round bar, square bar, steel tubes, steel plates, all are used. So main thing is how do you choose this choice of different types of section, right? The main question is what type of section you choose to design the building, right? So it is governed by sectional properties and availability, mainly right? So what type of sections popular in India and which is mostly used in India, which is ISMB, ISMC, and equal angles, right? So channels are used in purlin. T and angle sections are used in a truss, and basically I sections mostly used in beams and columns. So here we fix that this mostly channel sections for purlin, and T and angle section in truss, and I sections are used in beams and columns. So other types of sections are also used, which is a built-up section, step section, wide flange, hybrid, coal from, which is formed from the light gauge steel strips. So these are the industrial building. As you can see that there are different types of sections provided, right? Different types of different things provided, which is roof cladding, roof curb, skylight, ridge ventilator, purlin, rafter, column bracing. So in this type of structure, there are this all are the steel structure, right? And different types of parts are given in this. And we deeply studied this industrial building in this second chapter, right? So in the third chapter, then what are the loads on the structures, right? The first one is dead load, which is a self-weight and firm load, which is provided in IS 875 part 1. Second one is live load, which is changes from time to time, person like person moving in this structure, or furniture we moved from one place to another. So this all are considered as a live load, right, which is in IS 875 part 2. Third one is a wind load, right, which is basically in IS 875 part 3, then AL, which is I 8 A75 part 5, and then EL, which is earthquake load, which is IS 1893, right? So basically we all need this four type of load, which is dead load, live load, wind load, and earthquake load. So what are the loads, right? So simply loads are this some sort of forces. So there are major type of loads. First one is a dead loads. We can see that in this figure, the red arrow represent the dead load. Why? Because it exerted by the weight of element of the structure. Here some roof is provided, roof is resting on this both frame. So because of the roof there are some self weight of this roof, and which is exerted by the weight of the this own element, right? The next one is a live load, which is the rest arrows, which is identified as a blue ones, right? So blue arrow is a live loads. So it is exerted by any temporary force acting on the structures, right? It means if wind force is coming to any directions and applied on the structures, so these all are considered as a live load. Next one is the dead loads, right? So dead loads are those loads which are considered to act permanently. They are dead, stationary, and unable to remove, right? So the self weight of the structural members normally provide largest portion of the dead load of the building, right? So as you can see the previous figure, these are this main reason, right? So dead load means the dead load means the mainly dead and which is unable to remove, right? The load of this members which is fixed to the structures, right? So it will be fixed, there are no moving loads, right? Next is live load. Live loads are not permanent and can change in magnitude, such as people, furniture, or whatever. They include items found within a building, right? Next one is a wind load. The winds, a relatively large projected area, can develop sustainable forces in the structure. So here, for the example given in the covered bridge destroyed by the wind, right? This bridge is destroyed by the wind because this is the main reason. We don't know what happens in the future, so we can ready for any situation and consider the wind load as our design. So we are securing our future or the structure, right? So main basically we consider wind load for that reason. If in the future there are wind loads here, so our structure is protected because we consider as a design in a due to wind load, so damage are not happen, right? Next one is the earthquake load. So earthquake loads are another lateral live load, right? So they are very complex, uncertain, and potentially more damaging than wind load, right? Because wind load is only in the atmosphere, but earthquake loads are basically from the earth. Means it's basically coming from the vibration and because of the moving of tectonic plates and etc. There are because our structures are basically from because our structure foundation is basically is on the earth, right? So it is a very disaster when earthquake loads are coming, right? So mass tends to remain its own original position. Deformation due to sudden ground moving take place at the base, right? As you can see in this figure, the first figure is where a normal building, there are no earthquake load. The second one is if earthquake are coming, then this mass tends to remain its original position and swing it like this, left to right, right to left, right? So building have been demolished by earthquake loads that happen because it have not been designed to deal with these forces, right? So you can see this picture, it will be destroyed, it was destroyed because of this major earthquake loads. So it is necessary to design the building according to the both wind load and earthquake load. So we can there are not possibility that the structures are not damaged, but sudden it is designed that it will not collapse suddenly, so that we secure our home, right? See, there is a security check for our people who are living in the home, right? Next one is a load combination. So designing steel or concrete structure involves considering combination of loads. Therefore, most structural engineers are quite familiar with assessing the probability of barrier load combinations. For an example, it is unlikely that any bridge will need to resist full design vehicle load, design wind load, and the structure self weight simultaneously, right? So load combination is clear in this figure. We can see the dead load and the live load included. It's kind like a weight of furniture and people, wind load and slow load. So consider this design as a dead load plus live load plus wind load plus earthquake load, right? So these load combinations are important for us. So here we added our chapter here, which is first one is introduction, means loads and load combinations, right? So if you can have any query regarding this lecture, you can directly contact me, so I can solve your issue or doubt, right? So thank you so much.